Hello friends, welcome back. In today's lecture, I am Dr. Milind Meshram, working as an assistant professor in the Department of Chemistry, CHEM College, Nashik. In the last lecture, we have discussed the general methods for the preparation of alcohols. Okay, so we have seen three methods such as Grignard synthesis, ester hydrolysis, and reduction of carbonyl compounds. So in Grignard synthesis, we have discussed the synthesis of primary alcohol, which can be prepared from formaldehyde. Then we have seen the synthesis of secondary alcohol, which can be obtained from acetaldehyde, and tertiary alcohol can be prepared from ketones. Tertiary alcohol can be prepared from ester as well, except ethyl format. Okay. Then second method is ester hydrolysis, where the hydrolysis of ester will give the corresponding alcohol and acid. Okay. And finally, the third method was reduction of carbonyl compounds such as aldehyde, ketones, acid, esters. Okay. So in this lecture we will discuss the properties of alcohols. First of all, we will discuss the physical properties of alcohols. Okay. So as we know, the lower alcohols are liquids at room temperature. On the other hand, the higher ones are solid. Alright. And these alcohols are having the higher boiling point due to the presence of intermolecular hydrogen bonding. The boiling point order is primary alcohol would have higher boiling point than secondary alcohol, which in turn is more boiling point have than tertiary alcohol. Alright. The solubility of alcohols decreases with the increases molecular mass due to the decreasing extent of intermolecular hydrogen bonding in a particular alcohol. Okay. So physical properties. First one is lower alcohols have lower alcohols are liquids at room temperature. On the other hand, higher alcohols are solids. Okay. Second property is these alcohols have higher boiling points. Okay. Due to the presence of intermolecular hydrogen bonding. Okay. So here these alcohols have the higher boiling point. Okay. Bonding. The boiling point order is primary alcohol have a higher boiling point than secondary, which is having more boiling point than tertiary alcohol. Alright. Third property is solubility. Solubility of alcohols in water decreases as the molecular mass increases due to decrease in the extent of intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Okay, so these are the physical properties of alcohols. First one is lower alcohols are liquid, okay, at room temperature, while higher alcohols are solid, okay. And second one is these alcohols have higher boiling point due to the presence of intermolecular hydrogen bonding. Alright. And third, the boiling point order is the primary alcohol is having the higher boiling point than secondary alcohol, which in turn is having higher boiling point than tertiary alcohol. Okay. The third point is solubility of these alcohols decreases as the increase in molecular mass. Okay, due to the decrease in extent of hydrogen intermolecular hydrogen bonding. All right. So solubility will decreases as the molecular mass increases. All right. So these all are physical properties. So let us have the chemical properties. So all these chemical properties or chemical reactions are determined by the presence of hydroxyl group in the alcohol. Okay. For example, as we have discussed earlier, so these are to be alkyl or substituted alkyl group. Okay. So in this CO bond and OH bond. Okay. So either there could be a cleavage in between carbon and oxygen, okay, carbon and oxygen bond, or oxygen and hydrogen bond. Okay, so reaction reactions of alcohols involve these substitutions or elimination reactions. So it can involve either this COH bond, okay, COH bond breaking, okay, like this, or this OH bond breaking, okay. So in this removal of OH group, and in this the removal of hydrogen, okay, removal of hydrogen. So this reaction involves the substitutions or elimination reaction. Alright, so let us have the reactions. So first one is reaction involving cleavage of oxygen and hydrogen bond. Okay, so this reaction follows the primary alcohol, then secondary and tertiary. Okay, so when, for example, ethanol, 2 mole of ethanol reacts with sodium, so it generates this sodium ethoxide, okay, sodium ethoxide along with this hydrogen gas. Okay, so in these reactions there is a cleavage of this OH bond. Okay, so this alkali metal, when reacts with ethanol, it gives this sodium ethoxide along with this hydrogen gas. Okay, so in this reaction there is a cleavage of OH bond. Okay, and in primary alcohol this reaction rate is more. So in this reaction follows the order: primary alcohol rate is more than the secondary and then tertiary. Okay, in this reaction alcohol behave as a weak acid. Alright, so when it reacts with electropositive metal like sodium, magnesium, calcium, okay, so it generates alkoxide, okay, metal alkoxide along with the liberation of hydrogen gas. Alright, second one is reactions involving cleavage of COH, okay, COH bond. Alright, COH bond. The second reaction of alcohol is which involves the cleavage of COH bond. Okay, so in this the 3 types of alcohols can be determined. 3 types of alcohol, for example, primary alcohol, secondary alcohols, and tertiary alcohol can be determined by Likos test. Okay, so when these alcohols reacts with Aqueous reagent, that is concentrated hydrochloric acid and anhydrous zinc chloride, okay, to form the insoluble alkyl halides, okay. Primary alcohol concentrated HCl anhydrous zinc chloride, very slow at room temperature. Okay. Secondary alcohol is concentrated HCl in the presence of zinc chloride, okay. Alkyl halide in 5 minutes, okay. Alkyl halide, that is white turbidity after 5 minutes. Then we have in tertiary alcohol is tertiary alcohol and reacts with concentrated HCl in the presence of anhydrous zinc chloride at an aqueous reagent and gives alkyl halide white turbidity immediately. Okay. Immediately. White turbidity, instant white turbidity will appear. Okay. When you react this primary alcohol with concentrated HCl in the presence of zinc chloride, so it does not show the white turbidity, okay, at room temperature. So that reaction is very slow reaction. And when you treat this secondary alcohol with zinc chloride and concentrated HCl, it gives the corresponding secondary halide. So it shows the white turbidity after 5 minutes, okay. So that means the reaction rate is more than that of the primary alcohol. On the other hand, when you treat the tertiary alcohol with concentrated HCl in the presence of anhydrous zinc chloride, it gives the corresponding alkyl halide, okay. So it shows instant white turbidity, okay. So it means the tertiary alcohol rate is highest in this series, okay. So by applying this Lippers test, these 3 alcohols can be easily distinguished, okay. So it follows the order: tertiary alcohol, Since this reaction follows the HN1 mechanism, okay, and HN1 reaction is most likely to happen in tertiary alcohol, okay. The rate of the HN1 reaction is most in the tertiary alcohol, okay. So third one is the esterification. When organic acid, for example acetic acid, reacts with ethanol, it gives the corresponding ester, okay. So third reaction is esterification. Esterification. When organic acid reacts with alcohol, presence of H2SO4 or HCl, it generates the corresponding ester, okay. This process is called as esterification. Alright. So when alcohols react with the acid, okay, in the presence of mineral acid, for example H2SO4 or HCl, it gives the corresponding ester, okay. This is known as esterification. The alcohol, for example ethanol, here we are going to see the COH cleavage, okay. So when this ethyl alcohol reacts with acetic acid, okay, this is the acetic acid in the presence of H2SO4 or HCl, it gives ethyl acetate. So this is ester. Alright. When alcohol reacts with acid, for example acetic acid, in the presence of H2SO4, it gives the ethyl acetate, that is corresponding ester. Alright. So in this there is a cleavage of this COH bond. Alright. So let us have its mechanism. Since this esterification is undergoing in the presence of mineral acid, so it follows the mechanism where in the first step this protonation will occur, okay. So H plus, so here protonation will take place in the first step. have this ethanol. So nucleophilic attack over this carbonyl group and this double bond will get open to get this kind of moiety. This oxonium ion, okay. Then this proton will transfer to this OH to give this kind of moiety. Like here it becomes the good leaving group, and here OET. Alright. So now in this structure there is a presence of this good leaving group. Okay. Now this leaving group will get depart to give this kind of structure OET. Okay. And in the last step this proton will get eliminated, okay, to get this corresponding ester. Alright. So this is how the mechanism for this esterification. Since this esterification is undergoing in the presence of acid, so in the first step there is a protonation. Okay, there is a protonation will happen. Then after protonation, the nucleophilic attack of this ethanol, okay, or this carbonyl carbon will generate this oxonium ion, and after proton transfer to this OH group, it will generate this good leaving group. Okay, so this OH2, that is H2O, is good leaving group, so it will leave, okay, and form this oxonium ion, and in the end this elimination of this proton H plus, okay, to give the corresponding ester. Okay, this is how the mechanism is. So similarly, this acid chloride or acid anhydride will also give the ester. Alright, acid chloride or acid anhydride. So in this esterification, the acid chloride or acid anhydride can give the corresponding ester when it reacts with alcohol. Okay, so in the presence of base like pyridine or triethylamine. Okay, so when this, for example, ethanol reacts with acetyl chloride, so this is acetyl chloride in the presence of base like pyridine, okay, or triethylamine or triethylamine, it gives the corresponding ester, that is, this is ethyl acetate. It is ester. in this way, from acid chloride or acid anhydride we can generate the corresponding ester. Okay, so in the first reaction, when ethanol reacts with acetyl chloride, okay, this is acid chloride. So in the presence of base like pyridine or triethylamine, so this is triethylamine, okay, so it gives the ethyl acetate along with this acid. Okay, similarly, when you react ethanol with acetic anhydride in the presence of pyridine, okay, it gives the ethyl acetate along with the acetic acid. Okay, so this is the this second method is good than this acetyl chloride because there is a formation of hydrochloric acid. But in the second reaction, when you use the acetic anhydride, in that reaction there is a formation of acetic acid, which is more safer than the HCl. Okay, so generally this second route is more better than this first one. Okay, so this using of this acetic anhydride is better than the using of acetic chloride because in that reaction there is a formation of hydrochloric acid. So this is all about the today's lecture. In the next lecture we will discuss the oxidation reactions of alcohols. Thank you.